Hello everyone, welcome to the third part of the video series where we develop a simple to-do list application in C. So in the previous video we were able to create a simple web server in C, and whenever we make a request to the server it was able to get the request body and print it to the console. So this is where we have reached so far, and you can see that it prints everything into the console. So in this video let's focus on parsing these headers and also the method and the path, etc., and saving it into a structure so that we can do some operations on it later. Okay, so first of all we need to create a couple of structures to store the headers and some request information. So let's start with the header. I would call it HTTP header. Okay, and also another one for keeping track of the request. Okay, so the header is going to contain the key value pairs, and the request is going to contain the list of headers, the method, path, and the body. Okay, now let's go to the C file and start defining the structure. So the key and the value. Pretty simple. Now this is HTTP header. Now coming to the request. What do we need? Let's keep track of the method. So the method, the path, I'll skip the version for now. List of headers and the body. Actually I can do this. I can do this method path, then HTTP header. I'll need a double pointer because this will be an array of HTTP headers. Then we also need to keep track of the headers count, so we know how many headers are there in this pointer, and also the body. Okay, looking good. So compile, make sure I didn't mess up anything, and in the run method, so we have the buffer here. So now let's write a method to parse this string and return an object. I shouldn't call object, return a pointer to structure, a pointer to the record structure. So inside that method we can write all the logic to the string manipulation, etc. Okay, so we need to define a function for that. So this will return a request pointer. Let's call it parse request. So this will take a buffer. So let's make it a const so that we don't accidentally change it inside. And let's start defining it here. Okay. So first of all, let's create this. Get to malloc. Okay, we have the request object and return it at the end. So we need to use the str doc underscore r method. Str, yeah. So this is the method for str doc r. It takes a string and a delimiter and also a pointer to the string. So strtokr takes a character pointer. This will be the buffer, a delimiter. So we need to provide a /n as a delimiter so that we can split by each line. And also it takes a save pointer. So each time we call the strtokr function, it's going to update the save pointer to point to the latest position it has found after the delimiter, so that we can call it in a loop. Okay, so it's a pointer to there's also a method called strtok, but it keeps track of this internally. So it keeps track of the position internally, so it's not a thread safe method. Okay, so let's use it. So in order to use a save pointer, this will modify the original array. So since we are passing a constant buffer, we'll have to make a duplicate of this. I'm gonna call it cast rest. Let's use the strdup function. So this will create a copy of the buffer. Okay, and after that let's give one for storing the token. strtok, let's go r. So this will use the whole buffer as argument, and actually let's start parsing only the first line. So here the delimiter is a space, which will give us this 3. So this is the delimiter, and we also need to pass the pointer to rest. So essentially this is a duplicate of the buffer, and each time we call the strtok buffer, it's going to, the first time we call this, it's going to loop to iterate through this buffer starting from the beginning, and once it finds the space, it stops there, returns the token, and also updates the buffer, the duplicate of the buffer itself, to start from there. Okay, so next time we call it, it'll start from right after the first find. So here we have this first token, so that will be the method. So request method equals to token. Okay, and we can do this again. This time this is going to be the path. Okay, so it's time to test it. So we are pinned in the whole buffer here. Let's do equals to parse request, passing the buffer. Okay, and then let's print the method. If I can type. Let's put it in an angle bracket so that we know if we are if there are any additional spaces or characters. So request method. Okay. Ooh la la. Printf. Printf. assignment to char from char star. Request path equals token. Path is a char star. What did we miss? Token is a char star. Okay, let's try. What? Ah, come on. So the make will rebuild only if we make a change to the file. So request path is int. Interesting. Okay, so I think I know what's going on here. So strtok r, strdup, these functions are not part of the C standard. So we'll have to modify the make file to use GNU standard. And modify the file to make it run. Okay, much less errors now. Slash s expects I will write request path is an int. Why? Why? What did we miss here? Pretty sure it should not make a difference, but let's see. Huh? Interesting. So again we got empty reply from server, which is expected. So okay, good. So we have the method printed here correctly and the path printed here correctly. So we started parsing this buffer. We got until here now. And we can continue parsing the same way and get the HTTP version as well. But let's keep it for now and start parsing the headers. So here we are. So since we are not parsing the version, we need to skip to here. So right now the variable rest is pointing to the buffer starting from here. So what we need to do is find the position of the next /n and modify the array to start from there. Okay, so for that we can use strchr command. This will take the array /n. So the rest should start from here. This gives us the pointer to the first /n, so it should start from the next position. We need to do some memory management here and make sure we free it correctly, but let's keep it for later. At the end of the series we will do some analysis of the whole memory management and make sure we are doing it correctly. But for now let's focus on functionality. So we are starting it from here and so here we have a /n. So if I do a post using HTTP, it's going to have the headers followed by a double new line and then the body. So in order to parse the headers, we need to stop here, right here. So this is a /r/n/r/n. So we need to find the position of that, and for that we can use the str function. So this is used to find the substring in a string. So in the buffer, let's use buffer here /r/n/r/n. Okay, so this gives the position. So in order to initialize the headers array, we need to know how many headers are there so that we can assign memory for them. So what we can do is we can loop through the buffer until this point and see how many new lines are there, and that will be the number of headers. Okay, so let's call header count equals to 0. Okay, for char star p equals to, so starting from buffer, p less than position. So this is a pointer which will start from the beginning of the buffer and to go until this position. Okay, so each time we have a/n, we just increment this. Okay, and then we can store this headers count equal to header. Okay. So now with that we have the number of headers, we can allocate the memory for headers. So malloc header count into size of header, size of the HTTP header structure. Perfect. Let's see if we are missing anything. Initialization discards const qualifier. Okay, so since we are passing buffer as a constant, we need to make this as a constant as well. Perfect. Do you mean header? Is there no headers? Okay, so be headers. Okay, perfect. We don't have anything in the headers yet. Now let's try to do the strtok magic again. Let's do a while loop here. So while token equals to strtokr, continue with the rest, and then the delimiter will be /n again, pointer to rest. So if this is not null, that means we have a token. Okay, then what do we do? HTTP header equals to, let's initialize the header. Let's keep it simple. Malloc size of, okay, so we have the key, so we need to find the key and the value out of this token. So this token is going to be an entire line. Let's see, so this token is going to contain this entire line, so we need to split this again based on the first occurrence of this. So that will be the key, and after this skip the space, and that will be the value. Okay, so we do another str token. But this time the delimiter is a space, is a colon. Okay, so here we are using token variable instead of the rest, so we have a copy of that in the, we have a copy of the token here, so we are operating on top of that. So we have the key here, and so for the value, so after parsing the key, since we are passing it as the last argument in the strtok function, we can just the token variable is going to contain this part, but since we don't care about the space, we can just move it by one location. Okay, so head value equals to, okay, so we need a loop variable here, int n equals 0. So here we created the header, parsed it correctly, I hope, and then appended it to the array. Perfect. Now we need to start printing it. Actually, before we do that, so we have finished parsing this much. That means anything which comes after that is the body. So let's keep it in the body. So the rest of the thing will be in body. Perfect. Now in our web server run method, we can print this and hopefully it works. So we need a loop variable to go through the headers, header count, headers count. So key and value. Key and let's also print the body. Okay, hopefully, whoa, it compiled without any issues. Let's try a curl and segmentation fault. Isn't it fun? So what do we have here? We have method, we have path, we have the host, user agent. So the headers are getting passed correctly, and I think we missed something here. Okay, I think there's a bug here. Okay, so here we are starting to parse the token from the rest, which contains everything including the headers and the body, but we had to stop right after the end of headers. And the easiest way I can think of is to check for /r/n, because this will contain, so each time let's see how the token will look like. So here the token will contain this line, here the token will contain this line, here this line, but here it's empty. So the token will contain just a new line. Actually not a new line, it will just contain /r, and it will continue parsing with the body. Okay, so we can just check if the token contains, come on, equals to /r, we can just break it. Okay, nope, that's not it, but at least we made progress. So it's not printing the empty one. Okay, what else did we miss? Let's try a post, http post. Okay, everything is coming correctly except that segmentation fault at the end. I think this fault is coming at the body. So if we avoid the body for now, it should work, hopefully. Nope. So it's also possible that we have counted the headers incorrectly and have a interestingly, we can just break when the count has reached instead of checking for this. Let's debug a bit further. So here, let's also print the headers count. What happened? So let's print the headers count here and make sure we have the count correctly and allocating it correctly. So we need a curl headers 3, which makes sense to me. We have 3 headers. Okay. Sometimes it's the simple stuff which okay, forgot the loop variable. Make run curl, perfect. HTTP post. So method path headers host body. So we can remove this print message. Try again. Because connection method post headers count is 7. Host explain coding content length body. Okay. So that's it. So we have parsed everything correctly. In the next video, we'll see how we can use the path variable to do different logic based on the which path the user is requesting and the method. Okay, thank you.